we will have another Moore's law equivalent where it doubles every year. Then there might be some phases where we do that. I would not be surprised if it was doubling every year right now. But the notion of doing a quantum computer that had 1,000,000 entangled bits is, I don't want to call it fantastic. And people will always tend to say, well, think about what happened with computers and transistors. Um, Trying to keep a whole bunch of things like that entangled is quite a lot different. It's the difference between trying to keep a choir of 5 people on a chord and try to keep 1,000,000 people singing all at the same time. And those have to stay entangled, and you have a very short window while they're entangled to actually take that photo. There's not a very long period of time of coherence, and it all has to be done at very super cold temperatures. That's just the hardware end of making sure it happens. Then, of course, there's, as we were mentioning earlier, that whole algorithm question. You can't solve a problem like this unless you know what to ask. The ability to randomly look at every page of a book in a library is great. If you don't know how to find out which one of them pulled the right result, though, it doesn't help you much. So it has great options for things like searching, as we said earlier, but that all has to be taken in the context of when is it going to be faster than a classic computer. And until quantum computing starts getting to the point where it can um, really start having many millions of qubits entangled simultaneously, that's probably not going to happen. And even then, when we start hearing about ones that had 1,000,000 qubits, it's more likely that it would have packages of about 1,000 that were entangled instead of one that was actually 1,000,000. You have modules to a certain size. And the question will be, what is the biggest module we can make? And then you can start putting them in parallel, just like we do with other computers, but they won't be rising exponentially. You wouldn't have 2 to the 1,000,000th numbers of options available to you. You just have 2 to 1,000 times 1,000, which again would be an insanely huge number itself, but nowhere near as big.